about one thing. Oh, I messed up on this one. I forgot about the cube here. Uh-oh, so this is actually being cubed there. Oh, okay, so this is going to be not this. Let me just rewrite this here. So let me just quickly do this again. Forgot about that cube. So let's see. So it'll be 16 over 81 divided by 8 cubed. That's 8 over 27. So that's 16 over 81 times 27 over 8. So that's a 2. That's a 3. So 2/3. Right? Yep. This is a cubed. This is 16. Yep, that seems about right. Okay. And now multiplying by that 3 gives you the 9 over 2. There we go. That makes a little bit more sense. Okay. All right. So this is going to be 9 over 2, or 2 over 9, sorry, times that. And that's a cube in the bottom, so we actually get a secant at the bottom here. So this is when we got to slowly make sure you pay attention correctly. One subtle mistake can change everything when it comes to it. Okay. All right, and then finally we keep going. So we're going to do the same process we did earlier and convert this to sine and cosine. So again, after a little bit of manipulation, we get the integral of sine to the third x over cosine theta. This is squared d theta, and this we have this on the outside. Okay. And now notice this goes back a couple sections. Actually, last section, where we had powers of x and sine. So in this case, we had sine. Sine as being an odd power. So therefore, we're going to break it up to make it look like this. So yes, we can combine sections, even though we just finished one. So it makes these horrible to deal with. So now, according to those techniques, we're going to let u equal cosine. So therefore, du is equal to negative sine. Okay, so du, or the theta. So this ends up being negative 2 over 9ths integral of 1 minus u squared over u squared du, which makes it a little easier to simplify, right, when it comes to it. So don't worry, we're actually almost done, right? I know this is a long process. Okay, all right. So simplifying this a little bit again, I'll just write over here. That's another way to write that outright, is this portion. That portion just goes away. So the integral of this is just going to be right over here of u to the negative 1 minus u. And now plug in what u was to begin with, was cosine. Okay. And now lastly, this is theta, is using our triangle. All right, so going back over here, this we're going to be working, right? So technically tangent theta is equal to 3x over 2. So according to our portion, it's going to be 3x, 2, and then 4 plus 9x squared there. And since we want cosine, it's going to be adjacent over hypotenuse, but it's negative, so it's just going to swap places. So the first one, I'll just write it on the outside, is going to be over 2 minus this flipped. Plus c. And there we go. That horrible equation is finally done. So it can be pretty messy when it comes to it. All right, let's try another one. Find the integral from 0 to 3, so now we have bounds, of x divided by the square root of 36 minus x squared. Okay, so this one is different than what we had, right? This is a squared minus x squared. Therefore, we have situation A, right? We have a squared minus x squared, so we're going to be using sine in this case as our substitution. All right, so we know a is going to be 6. So we're going to have x is equal to 6 sine theta. Therefore, the derivative is going to be 6 cosine theta d theta. Okay. And then we just plug it in and see what we get out, right? So this is going to be an integral 0 to 3 of just x, so 6 sine theta times dx, which is all of this, all over this. Okay. And again, just just go a little faster. We know if I just factor this out, we get 1 plus sine squared theta, right? So in the next process, I'm just going to quickly skip a little section because I'm sure you guys can pay attention going that way. So 6 times 6 is 36, and then sine theta, cosine theta on top. And then this ends up being, right, this is cosine squared, so taking the square root gives you 6 cosine theta, right? So if I take the square root of this is now just 6, and this is the property of just cosine squared. Taking the square root gives you just one of them out back, right? Same as the top ones. Okay. And again, right, it's a little easier because we can simplify. So cosines cancel, and that gives us being 6. So I'll just put that on the outside. So cancel, cancel. Oh, this is super nice because now in this ends up being integral of just sine theta. Right? That's a super nice one. So integral of sine is, I believe, cosine, right? Evaluate 0 and 3. Okay. So this ends up being, again, going back over here, we have to do our little triangle. But now this time, sine theta is equal to x over 6. So again, knowing that sine theta is opposite over hypotenuse, so this is opposite over hypotenuse, so this one here is x squared plus 36. Okay. And now we just evaluate cosine. It's going to be 6 times cosine, which is adjacent over hypotenuse. Oh no, why am I talking? This is a minus, right? Yeah. 36 minus x squared. That's on the inside. all over x. Oh, 6. Evaluate it at 0 and 3. Okay. And now we just plug in check, right? Notice that 6 is actually cancel, which is super great. So let's go away and we just plug in 3. That's going to be 9. So 36 minus 9 is going to be 27. Minus when you plug in 0, that's just going to be 36, what is 36, which is 6. Oh, and I almost forgot. That was right, yeah. There should be a negative there. Yeah, for something I was a little off there. Now, the fun thing is, and you guys are going to hate me for this, you actually didn't have to go through all of this mess for this type of question. Okay, so if you're wondering what I mean by that, if you were slick, you would have noticed you all have to do this. You could just do a straight substitution method. So let's see. Let u equal everything on the inside. Then du is going to be negative 2x dx. Notice I don't have a negative 2, so it's just going to be negative 1/2 du. So therefore, this ends up being integral from 0 to 3 of negative 1/2 of 1 over square root of u. And look at that. Okay. So if you take the integral of this, it means you add it, so it's going to be positive 1/2 times 2. Evaluate at 0, 3. Oh, and then the negative 1/2 is on the outside. So plug in check in what it was to begin with. So these cancel. So you get negative on the inside, or the square root of 36 minus x squared, evaluated at 3 and 0. What you notice gives you the exact same thing. Voila. Square root of negative. So, appreciate me, right? So, sometimes you don't have to use our technique here. Sometimes a straight U substitution is the way to go. Or, and like you notice, right, there's more than always one way to do stuff when it comes to this. So, I'm sure you guys hate me for it, right? Having to do this. Right? So, that is trig substitutions.